Hi everyone, welcome back to our channel Learn with Jokes, and today we are trying our best to see another problems from trigonometric identities. This video is actually the continuation of the question that we have discussed before regarding trigonometric identities. And here Jokes already prepared three questions for you to discuss together. Now, let's get started with the first question. The first one, question A. Oops, sorry. Question A. We have cosine to the power of 4 x plus sine square x is equals to sine to the power of 4 x plus cosine square x. So as usual, we try to prove. Now we try to prove this. Okay. For this, as the first stage to prove this, I prefer to choose this side, which is the left hand side. So we mark this as the left hand side. Okay. I take this expression and I'm gonna try to prove whether the expression on the left-hand side can be written as the expression on the right-hand side. Okay, so this is right-hand side. So students, please pay attention, yeah? Cosine to the power of 4x plus sine square x. Okay, the next step, as you see, right, this is the power. The power is 4, right? So power index, they are the same, yeah? The power for cosine is 4. So I would like to make it like this, bracket. Inside I have cosine square x, and outside of the bracket we have square. Is it the same thing mathematically? Yes, of course, this is the same, right? Plus sine square x. Okay, what do you think for this? Can you follow me? Yeah? So is it the same, right? Isn't it? What do you think? Yes, of course, it is the same, right? Mathematically the same. And then, once again, by recalling what we have, once again, that sine square x plus cosine square x equals to 1. So here I'm trying to figure out cosine square x, or let's say we change this in terms of sine. So this is what we have. Okay. So cosine square x, if you notice this basic trigonometric identity formula, what will we have? 1 minus sine square x. Don't forget the square outside of the bracket plus sine square x. Okay. Then the next process is try to what? Look at this. Expand this one. So we expand this one. Yeah. Remember expansion? Yeah. This is binomial, right? Binomial expansion. We try to expand this. But of course, this is easy because we have here the power is 2, right? So remember 1 square, which is 1, and then this must be 2 times minus sine square x times 1 is minus 2 sine square x, and then this become plus sine to the power of 4x plus sine square x. Now, as you see here, this is the expansion of this. Okay, this is the expansion of this. Can you get it? Are you with me now? Okay, that's really good. And we continue. Yeah, so basically, then the next thing is what? So mathematical operation, this is 1, am I right? This is 1, okay? I write 1. Now you have this. Look at this 1 and this 1. Sine square with sine square. But notice the sign is very important. Negative or minus 2 sine square x plus sine square x. It will give you, of course, negative sine square x. Am I right? Plus sine to the power of 4x. Now, after this, we almost reach the final part of this, yeah, of this problem, which is then recalling again this one. Remember, by recalling once again, see, this is very important. Sine square x, x cosine square x, which is 1. Then I can write this become what? Cosine square x plus sine to the power of 4x. Now we check with the problem. Is it the same? Yes. It's the same, right? It's proven, right? What do you think? Is it difficult? Hmm? Not really. Once again, the idea is we need to remember all the basic trigonometric identities formula, such as what I wrote here, sine square x plus cosine square x equals to 1. That's really interesting. Yeah, that's for the first question we have today. Now we continue with the second one. Now we come to question B, the second question. Here I have 1 plus cotangent x out of 1 plus tangent x, which is cotangent x. Okay, so we try to prove this identity. Once again, this is our left hand side and this is our right hand side. And since you see here, yeah, the left hand side is the unique one. So I take this and then we try to simplify this into the right hand side. We prove whether it is the same or not. Yeah, then we start with this. Okay, I prefer to change cotangent with 1 out of tangent x. Yeah, since cotangent is actually the reciprocal of 1 over tangent. What I mean here, sorry, cotangent is actually the reciprocal of tangent. Yeah, and then I do nothing to the denominator. I keep writing the same. Okay, then after this, try to simplify the look at this. This one has the whole numerator. So I prefer to simplify first the whole numerator. Okay, so here I will have tangent x plus 1 out of tangent x. What do you think? Do you get it? Do you get it? I think you get it, yeah? Out of 1 plus tangent x. Oops, I forget x here. Yes, x is also x. Okay, I think no problem with the first one, yeah? Since this is fraction. Okay, remember this? Yeah, 1 plus 1 over tangent x. So we change 1 with fraction as well. So this is tangent x out of tangent x plus 1 out of tangent x. So now they have the same uh, denominator. So this is tangent x plus 1 out of tangent x. So this come from this. Okay, that's simple, yeah? Okay, next thing, yeah, we have fraction. And remember, fraction is division, right? So to simplify this, I make it into multiplication. So I flip this one, the denominator. So I will have tangent x plus 1 out of tangent x. I flip it right. It's multiplication now. So become 1 out of tangent x plus 1. Okay. Then what you can see here, look at this. Yeah. Cancel this, and yeah, since they are the same, right? Tangent x plus 1, right? And the remaining is 1 over tangent x. And once again, 1 over tangent x is the reciprocal of cotangent. So cotangent x. Now, as you see again, our question, yeah, it is proven. Ta-da! Okay. What do you think? Is it clear now? Yes? Wow, really, really good. Yeah, very interesting. Mathematics is always interesting. Hopefully you can follow the way I solve this step by step, or to figure out the identity to prove it correct. Any question? Yeah, if you have question, just put in the comment below. Yeah. We will continue with the last question. Okay, the last question, the third question.